Good morning, afternoon, and evening to everyone is connected with us from all over the world. Time is now. Never as today, we have to think about the future. How the new Factory 4.0 should be to support your business, but also to giving you the flexibility to follow the market change. I'm Marisa, and together with me is Chiara. She's connected with us from Chicago, where we have the Electric 80 North America headquarters. We are in charge of the System Analysis department, and today we will be speaking about how the Electric 80 simulation is an extremely useful tool in project design and concepting activities. We will see how this tool may help your system design. This is a live session. You can make questions through the way you received in the invitation. For all the questions we cannot answer, you will receive an answer in the next days. So, let's start. You might be a technical director, a plant or a logistic manager. You may be a production planner or an analyst. So how many times did you face this type of difficult question? Warehouse, logistic systems are complex systems affected by many independent variables. There are continuous flows going in, like production or external receiving, and there are flows going out, like shipment. Can be considered live system when if you capture a snapshot of different time windows, this snapshot may describe a complete different environment. For this reason, correctly size them is not a child play. When our customer, like you for example, came closer to the automation world, we know that the transition is not a straightforward path. We guide you to understand potential impacts on your logistics system. We base the analysis on historical data, together with future forecasts, but the traditional mathematical approach, only based on static input data, may not be enough to gather the complete system behavior. Complex systems require an extra effort. They require to be studied with a flexible tool that highlights the Electric 80 know-how. This is the reason why we add a dynamic approach, where input data change throughout the simulation time and follows the real trend of the event affected simultaneously. Also, variability and sequence of the events are part of the analysis. The static approach is not intended to be an alternative way of size a system. The static inputs are a mandatory step, while the dynamics complements this approach. Through the simulation, we can foresee future benefits and take you by the end in the transition between manual to automated. Simulate can help to see how it will be. This is Smart Designer, and this is the way we decide to call our simulator. Smart Designer includes specific libraries that are developed by E80 and E80 developers. These libraries function as the software does in the real system and as the system would in the real world. It uses Flexim as the engine, but all the E80's know-how influence the current behavior. From the library, we can drag and drop objects on the virtual environment. We can import the AutoCAD layout and then place the object on the real layout physical positions. We can also customize object parameters based on customer requirement through the user-friendly GUI or a custom code a custom logics to behave as the customer is requiring. Looks at this example of a simulation. And looks at the right side of the video. There are many dashboards and reports. For example, would you like to estimate what will be the real production per hour? Here are the histograms with the instant production per hour. Or would you like to estimate what could be the warehouse utilization? Here there are the graph with the warehouse saturation. At the end, would you, for example, monitor also the warehouse equipment utilization? Here they are the pie charts with the state tools utilization. Smart Designer provides reliable feedback with an accuracy up to 95%. We believe in the solution we offer you, and we are committed to the results. Can others do the same? With all due respect, I will explain you the differences. Why work with EAT? Why design with us? When we develop Smart Designer, we decide to include all the best practice of the Electric AT project that characterize the Electric AT project and the lesson learned in 40 years of experience. As of today, we have more than 280 integrated systems with more than 30 high-density warehouses and 5,000 LGVs already installed. So, Smart Designer include all this experience, of course, starting from the robots and the system, the robotic system, like, for example, LGVs, palletizer, and wrapping system. Their physical behavior, as well as the kinematic and dynamic aspect, as be considered. We consider, for example, how an LGV do rotation or movements, how he lift a pallet, or how, for example, a robot move the anthropomorphic arm. EAT know very well these aspects because we are designer of all the equipment we supply. But not only robot, but integrated automated solution that include high-density warehouses like cranes or smart storage and fully automated picking solution with layer and case picking. But simulator is not only a 3D environment where objects are moving. The real differentiator is the Smile EAT software, is the brain of the system. So we decide to replicate our Smile EAT software in Smart Designer, of course in a different architecture. But why? In order to replicate its behavior also in simulation. So why put this logic in Smart Designer? Why replicate the WMS logic in Smart Designer? Looks, size a system doesn't mean only define which is the best, the right number of LGV to replace forklift, or it is not only calculate the number of LGVs to move a certain number of pallet from A to B. Is the logic you apply that influence the results. This is why one of the main focus of the Smart Designer simulator is the warehouse KPIs, is the warehouse utilization and filling factor. So we did it with a higher level of details because we know that not going deeper in the simulation modeling means create a big gap in the resulted KPI. So doing it without being a designer or developer is a very hard work to do it, and this is the reason why often many engineering companies contact us to support them to achieve this goal. So let's summarize the main KPI that we can provide you. First of all, remember that we offer you reliable KPIs that are based on a solid experience and a deeply developed simulator. Properly size a system means give you the right value and the right output. But even more important, we commit contractually to performance in the real installation. To ideally represent what we can simulate, we decide to use this plant. It will work as an example like any kind of factory or distribution center. Indeed, we have different functions. We start from inbound, when we receive goods. We have production area, warehouse area, picking, and of course, shipping. We now jump in every single function to see how this model has been modeling and see a KPI that we analyze in different projects. We start from the inbound. Goods inbound is here represented with an inbound conveyor. The inbound conveyor is used as a connection point between the operator activities in charge of truck unloading and the LGV's activities in charge of store goods. The simulation can be used to, for example, properly size the inbound conveyor capacity in order to keep a flowing inbound rate, but also to help the customer to calculate the right number of operators required to unload received trucks. Based on the incoming flow, we can define different storage strategy of product, combining different scenarios of SKU mix. We now jump in the production area. The production area may be represented with the end-of-line parts of the production lines, where boxes are coming into the palletizer solution and pallet pattern is created. In Smart Designer, is it possible to create a realistic production plan, which may include all the information that is not possible to analyze with an static approach, like, for example, the list of SKU per line and his batch length. The line speed is usually affected by SKU, but also defining different setup time to the lines and insert a different line efficiency. Also, the line efficiency may be not stable during the run. We can also analyze the accumulation buffer conveyor before the pickup points in order to detect possible congestion or line blocking due to the accumulation. And of course, based on this, manage urgent call. Therefore, you can understand that the overall production pallet per hour, generally considered a static input of the simulation, may become an output of the simulation. We are now in the core of the system. We are now in the warehouse area. In our ideal layout, we represent different kind of warehouse strategies. We can have, for example, block storage locations. We can handle products in all type of racks, from selective to drive-in. We can also manage rack equipped with satellites, but also automated warehouse like a standard crane system or smart storage, our EAT solution, multi-depth pallet solution. So the simulation manage in real time the put away logic, evaluating different warehouse alternatives, different warehouse possible destinations. Simulate means no need to predefine which percentage of the flow should be sent to one area or another area in advance. Smart Designer will act as the real software does in the real installation. And of course, make decisions based on the physical dimension of the products and the intrinsic characteristics, but mixing them with the real-time warehouse utilization and equipment utilization to then define the resulted warehouse KPI and utilization factors. The ultimate scope of the storage strategy is to optimize the warehouse and the space utilization, but without forgetting the equipment utilization and the optimization of the automation, whether it is an LGV fleet or an automated system. Of course, any parameters and any rules that we set in Smart Designer, as they are input of the simulation, can be changed to then giving us the opportunity to compare different scenarios. We now go to the picking area. The picking flows and activities may include preparation where picking pallets are made up of only layer or only case, or can be the result of combination of two activities. Pallet can be pre-built in layer picking cells and then transfer to the case picking area to be completed with the ad-inclusive cases. In this first part, we see the layer picking cells. In the layer picking, we can simulate the layer picking robots and his number of cycles and the number of cycles that is able to achieve. We can properly size the handling system. We can analyze the mother buffer, area, and consider if it's enough based on the concurrent skew needed. And finally, considering the average pallet per layer distribution, analyze the average time to complete a pallet. But not only layer picking, also case picking. Also, the operator can be considered a resource of Smart Designer as an LGV. And in the case picking, we can evaluate the operator fleet, we can estimate their productivity, and we also can consider the layout heat map and analyze the path most frequently traveled. We are now close to the shipping area. The shipping is one of the most important activities in a plant. This activity can be performed in a different ways. Flows can be performed with shipment preparation, where we extract directly from the warehouse and pre-stage, temporary pre-stage in an area, or directly truck loaded on a truck. But even we did for the production flows, also from the shipping, we can create a realistic shipping plan, where we consider different dynamic parameters, like for example, shipment dimension. Trucks are not all equivalent in terms of dimensions. Also shipment composition in terms of SKU mix, but even staging sequence required by our customer, where our customer require us to group in pallet by delivery, or for example by SKU or other criteria. Then the resulted KPI we analyze allow us to define which is the space required for stage pallet, estimate the shipment preparation times, but even more important, analyze the dock rotation in terms of based on the average truck waiting time together with the loading operation. Then we complete the flow, and this is a big example of flow to be monitored. Of course, the aim of the simulation not necessarily need create such a big plant like the one that we see today. Also, a small part of the warehouse, a critical area or bottleneck, can be considered the scope of the simulation too. So let's review now the key point of the simulation and the simulation did with Smart Designer. First of all, we work using a realistic modeling of AutoCAD plant. This means that space and physical dimension are retrieved from the AutoCAD layout that can be easily uploaded on SmartSim. The core of doing simulation is to evaluate the behavior of a system in a protected environment. That's why one of the main goals is to create and compare different scenarios. And do it changing one or more variable. For example, one variable can be evaluate alternative layout, moving warehouses from one side to the other, or change the warehouse configurations. We can also set different flows configuration, or we can consider different what-if scenario. Like for example, what happens if one sector of the warehouse is not available? Or what happens if the line speed at maximum speed? Or what happens if, for example, for any reason, truck don't arrive for many hours? So all those questions can be answered through the simulation results. Another advantage is that by design, Smart Designer doesn't follow the real-time flowing of the events. Looks the clock. If you look the speed of the simulation, you can understand that we can simulate a long period of time in short real time. For example, doing a simulation along an entire year in a matter of minutes. But also, as you can see in the right part, Smart Designer has a built-in reporting tool that can be customized to create specific dashboard and charts. Some KPI can be observed in real time, and others can be analyzed at the end of the simulation. But even more important, the main KPI that Smart Designer is able to provide through the simulation also in the calculation method reflect the same way that the Electricity reporting tool calculate for the real installation. So that's why you will read results in the system design in the same way that you will use when you will drive the automated system. We want to leave you with these following 3 takeaway points. First of all, with this tool, we can evaluate and verify the performance of the overall project, providing contractual guarantees that we are able to commit during the life of the project. Yeti commits not only to the efficiency of a machine, but we want to give you to guarantee an integrated and automated solution. Smart Designer is a vital tool to achieve the maximum customer satisfaction. The second point is that this is a time-saving approach, because running simulation to evaluate and compare different functional behavior of a system allows you and your technical office to save precious time during the design and development of the project, going straight forward to the best possible solution. With Smart Designer, you can experiment in a safe environment before making any investment in equipment and with no impact on a daily operation. Furthermore, you can use it in the future to test different operational scenarios. With Smart Designer, the benefit continue after the initial investment is made. No risk, huge benefits. The only risk is not doing it. Thank you for your attention. We are now taking 5-minute break and we will meet later for the question and answer session. Welcome back to the Smart Designer presentation. As I told you at the beginning, today I'm not here alone. Together with me, there is Chiara. Chiara, can you hear me?
Yes, hi Marisa, and good morning and good evening to everyone. So I'm Chiara and I'm connected from Chicago, where we have our North America headquarters. So while Marisa, you were doing the presentation, I was taking a little bit like a look on the question that we received via email. So I believe we can start from some of these questions. Thank you very much for your participation today. And we received a lot of questions. So we will reply to some of them, and for the rest, we will reply to you via email as soon as we can. So, Marisa, one of the first questions that we receive is how did you design the object? So, and which physical parameter are considered, for example, in the LGV object? So, would you like to reply to this question?
Yeah. So when we design every object, we have the collaboration with our technical office in order to include not only the logistic aspect, but also the physical aspects. For example, in Smart Designer, the LGVs have forks that can be raised and lowered according to the operation to be done. Operation times, speed, acceleration, deceleration, all these kind of parameters are the same as the real LGVs and are different based on the type of LGVs. We also take in consideration the battery consumption. All the battery charging is an important operation that is included in the LGV utilization. For this reason, we do this approach and we do the same approach while designing also the other equipment. The following question, Chiara, is for you. One of our customers is asking, do you simulate equipment failures or alarms?
Okay, so our approach when we usually do simulation is to simulate a long period of work to understand the behavior of our system during this type of period. Uh, in this perspective, the machine alarms of failure could be negligible because they only affect the system for a short time. However, it is possible to create some parameter and some value, for example, the time between the failure or the time between restore for the equipment like LGVs or palletizer or even ASRS to study their impact on the system. This could be, for example, part of our what-if scenarios or exception scenario that we want to test during the simulation process that we agreed with the customer at the beginning of the project. But this is something that we can definitely involve and include in our study. Okay, so let's see here. So a customer is asking, while we do this type of simulation, will this replace the software development? So Marisa, can you help us to reply to this question?
Yeah, I would answer starting by saying that we have to split the software development in two main phases. The first one is the functional design phase. So in this phase, we design and we build a technical document that include the customer logics and also how our software is also interacting with other software, so all the software communication protocols. Then the second step is the software development and the test. So during the simulation process, we may analyze different scenarios and we might find and solve possible bottlenecks or critical aspects. Anyway, this first phase, I think that can be speed up with the simulation, of course. But despite the level of details that we reach thanks to the simulation process, Smart Designer is not the real Smiley 80 software. Therefore, the simulation cannot replace the software development prior to the installation. one of the next questions that we selected is this one, Chiara. This customer is asking, could it be possible to connect your simulation tool to our ERP?
This is a very common question, so thank you for the question. So the data that we use as an input for the simulation are, of course, retrieved from our customer's ERP. Actually, the data analysis is one of the fundamental steps in simulation. So together with our customer, we usually spend time to understand how their system works today, if it's existing, and how we'll be working in the future. So starting from the data and the future forecasting, we can create some profile, for example, production profile or shipment profile that reflects how the system works in simulation. With this kind of approach, we don't really need to connect the ERP to the simulation. And also, if you think about the real nature of the simulation tool itself that allow us to simulate with an accelerated speed, maybe the connection with the ERP could slow down this accelerated speed since there will be a sort of real-time connection. So for this reason, we don't really see an added value to connect the ERP because everything is already included in our simulation tool.
Yeah, thanks, Chiara. I perfectly agree with you. And another question that many customers are requiring is this one, in a different formula, but basically the meaning is the same. Is the simulation study subjected or a project agreement with EAT?
Of course not. Let's say that the simulation study is a service that we offer to our customer independently from the PO of a specific project. So at the end of the simulation study, we deliver to our customer a detailed documentation with all the KPI and the results that we agree on. And this will remain to our customer, of course. This could be, you can think about it as the first step in starting knowing electricity and start building sort of trust and trusting the capabilities of our technology. We definitely want to do this type of study to create a relationship with our customer and make them trust us. But thank you for the question. I believe it is very, very important. So let's see here. Another important question, I believe, is this one, Marisa. So our customer is asking us, of course, which is our average delivery time for a simulation project.
Yeah, it really depends on the project, but in general, any study is made up of two main steps. The first one is the data analysis. In this first phase, we interact together with the customer, we collect data, we analyze historical data, and then we define a statistic profile of the flows. So the duration of this phase really depends on the data availability and the customer responsivity, of course. But in general, we can estimate this first phase in a couple of weeks. Then we have the second phase. That is the phase when we build the model and we run the simulation and we define the results of the different scenarios. We can consider between 4 to 10 weeks to complete the second step. This is really depend on the project complexity and the number of scenarios to be evaluated and studied and compare it. So, unfortunately, now the time is over. So we have time only to answer to the last question. Chiara, I selected for you the following that it drew my attention. The question is this: can we use the simulator model as also after its system has been installed?
Yes, you can, because once the model is the simulation model is done and it's up and running, we can definitely maintain it, also upgrading it to the latest releases of Smart Designer, but also, and more important, can be integrated with all those functionalities and logics that maybe have been developed during the project installation and that they were not involved or included in at the design stage. So, for example, you might want to test and what is the impact on your system with an additional production line. We know that adding a new production line is not only affecting the layout, of course the space, but also the production rates, so the flow of your system, and the number of SKUs that needs to be managed. So together we can understand which are the changes to be done to the model, change it, running it, and together analyze the result. In this way, we can help you to make the right decision and to design properly the system. So let's say, as we were saying earlier, here the only risk is really not doing it. So I believe this time is over. So this was our last question. So thank you again very much for your attention today. I believe it was a great opportunity for us to show you our simulation capabilities. Of course, we will reply to all the other questions that we receive via email as soon as we can. So thank you, Marisa.
Thank you to you, Chiara. Thank to all for attending this presentation. I hope that it was an interesting session for you. Even in these difficult times for Rieti, it's very important to be close to our customer and to you. So see you soon to the next live event, and stay safe.